I want to introduce everybody in the room to Roger Yee. He's our senior application engineer based in our headquarters in Needham, Massachusetts. So he's in the office bright and early this morning. So Roger, you have a room full of Mathcad only resellers, PPC bars, covering lots of different territories within EMEA.
Well, thanks, Brent. As Brent said, my name is Roger Yee. I am calling you guys, well, I guess conferencing you guys in from the Needham office. And for the next 45 minutes or so, what I wanted to do is kind of give you, some updates on Prime, specifically Prime 2.0, as you guys, roll out to start selling this in a couple of months. Just a quick agenda. Let's first talk about how Mathcad has grown and has evolved over the years, over the past 25 years. We will cover some of the initiatives for creating Prime 1.0, some of the capabilities that were introduced. And then what I want to do is talk about some of the new features that will be introduced in Prime 2.0. And then from there, what I want to do is actually open up Prime 2 and give you a live demo so you can actually see some of the new capabilities in action. And then also we will do a little roadmap so you know that you can see what some of the things that we are planning for the future. So first off, the product evolution. Now I do want to point out, as you can see from this image here, so these slides are actually created by Dirk. So I'm going to try to speak to them as much like Dirk as he would. I think this image captures very well, how we evolved from some sort of a monkey species all the way to a scientist or engineer sitting at their desk in a very similar form. So product evolution. I will admit that I was not around during the earlier years of Mathcad, so I did not use the DOS versions. But from what you can see here in the screen capture, it was very clunky. It was not very easy to use. Now it did have a really strong math engine in the background to help you with calculations, but again, it wasn't really a document, and it was kind of hard to use. So these middle years was my first exposure to Mathcad. And there's a screen capture on the bottom right, so this is from the mid-90s. And as you can see, now we're actually starting to see more of this document that has become a trademark of Mathcad. So Mathcad is what we call a self-documenting worksheet. So as you type your calculations, you create this document. And the whole reasoning behind this is that oftentimes people complain that engineers and scientists do not document their work. Well, it's not so much that they don't want to, it's just that it's really difficult to. So Mathcad is really trying to make it easier for them to do so. And in introducing a nice graphical user interface, a nice GUI, what we also did was we introduced a lot more functions. We gave users a way to actually deal with calculations in a symbolic fashion. If you don't know what that is, don't worry. We'll be covering that in about 15 minutes or so. And also for the more advanced users who want to do more in-depth exploration, we also gave them the ability to do programming within Mathcad. And overall, it became a much easier to use tool. So with the GUI, with the user interface, it was just much less clunky than before. And as you can see from this bottom right-hand corner, this interface has pretty much stayed through, I would say, for quite a while. I would say even up until 15, you'll see pretty much the same window, obviously with more buttons, but more or less the same use and feel. Okay. Now let's talk about Mathcad today. So Mathcad today has become a more widely adopted tool across various companies and across all industries, but it's not really universal yet, and we'll talk about that in the next slide. Some of our USPs, our unique selling propositions, include that we do focus on the actual document. Right? I already mentioned that it's a self-documenting worksheet, and we are the only software tool out there to actually handle units. So in case you don't know, or in case you haven't seen this yet, we'll be covering this also a little bit later on, but we're the only software tool that allows you to mix, to use units, mix units, and also carry them through in your calculations. And finally, even though there are other softwares out there to handle symbolic math, we actually have a patented interactive way of dealing with symbolic math. And also some of the integration, I'm sure Brent has already talked about them, is that we can actually link to CAD or CAE products. So you guys know that PTC makes Creo, or what used to be called Pro Engineer. So we can very easily hook into that as well. as well as other Microsoft Office applications. Now, I won't have time to cover this today, but if this is something that you're interested in, we can definitely schedule something down the road for these other integrations. And then finally, I think Brent has also talked about how we can use Mathcad in a process strategy standpoint. And so if you integrate that with our PLM solution, then we can actually we can trace requirements, we can track changes, and so forth. So there are a lot of different ways that we can use Mathcad today. I asked earlier on, why is Mathcad not being used across all companies in a more universal fashion? And why is it that some engineers or scientists they just get Mathcad while others they're really hesitant to change? And then we can also ask why shouldn't given the symbolic capabilities of Mathcad, and given that it's really easy to document, why aren't more schools and universities using Mathcad? So I think we can answer some of these questions by saying that, well, there's a perception that Mathcad is a little bit difficult to use, right? So people who who have only seen the earlier versions of Mathcad think that, well, it's just like any other math software. It's going to take me a while to learn. And also, where some people actually think that, well, going from the out of the box, the OOTB, to what they finally want, in their final product, there's a lot of steps that they need to take. So they think that it not only does it take a while to learn, once they learn it, they need to spend a lot more time to actually get to do get Mathcad to do what they want it to do. And also, I think in the early 2000s, we weren't releasing that many releases of Mathcad. And so, it was limiting, certain companies' development in that they couldn't actually incorporate some of the latest features and so forth. And finally, there are a lot of people who are using Excel, and if they're happy with Excel, then they're actually really hesitant to change because, if it works, then don't break it, right? That kind of philosophy. So what we decided to do was to try to tackle all of these problems by introducing a new Mathcad. So that's how Mathcad Prime 1.0 came into being. So we decided to give it a new architecture. We really wanted people to start using it right away, very easily. So that was one of the biggest, one of the biggest focal points of rewriting Mathcad. And so we're hoping that making it easier to use, it will lead to a wider adoption of Mathcad. And so as you guys already know, Mathcad 15 is still around. It's a dual release strategy. So right now there's both Mathcad 15 and Mathcad Prime 1.0. Now in 15 we did release some capabilities such as DOE, design of experiments, and also we allowed it for customers to integrate to third-party softwares more easily. So there weren't a whole lot of new features from 14. But I do want to point out that 15 will be the will be maintained until all the features in Prime get caught up, right? So we will be releasing Prime on a yearly basis, but we will also be maintaining Mathcad 15 as well until we're all caught up, and then 15 will eventually be dropped. All right. So I want to talk a little bit about Prime 1.0. And as I've already mentioned, one of the biggest focal points was making it easier to use. So as you can see from the screen capture on the right, we adopted a new user interface. So everything now looks more kind of like the new Microsoft Office with this ribbon user interface, this ribbon UI. And also, if you use some of the other PTC products, you'll notice that it also looks more similar to some of our other products. We've made it easier for people to start using the software right away. In fact, one of our goals in creating Mathcad Prime was that if a person were to pick up the software and play around with it, that they should be able to know how to do, I would say, some very basic calculations within 15 minutes. So again, we're trying to erase that perception that Mathcad is hard to use. Actually, we think it's very easy, and a lot of the things that we put into Prime was kind of focused on that. Now, as I already mentioned, Mathcad is very strong for documenting, and we kept obviously those capabilities. So we're still making it very easy for you to format pages, to write equations, to perform calculations. But we're also adding some additional things. For example, we now give customers a much easier way to actually not only format specific regions within the document, but also if you want to apply a template to your document, we can also manage the header and footer content. The next couple of pages basically talk more about some of the features in Prime 1.0. I don't really want to cover all these different bullets, so you can briefly read through them. But same thing as before. We still have a lot of math capabilities. We have over 600 functions that allow you to do various types of analyses within Mathcad. Again, very user-friendly, very easy to learn. And so I'm going to now go through some of these bullets here. So these are basically a lot of the new things that are in Prime. I just want to point out a couple of these. So as you can see here, I've already mentioned that we have this new ribbon UI, right? So the whole point behind the ribbon UI, the ribbon user interface, is that you can get to everything that you want to do within 1 or 2 mouse clicks. So as opposed to having to go through various submenus, we can now actually just click on various tabs within the ribbon and hopefully find the exact task that you want to perform right away. I've already mentioned the header and footer. You can just click right into them and start formatting them. It's very easy to do so. And just like before in Mathcad 15 and prior, we can embed images and equations right into the document, right? And finally, what we say is Mathcad is a WYSIWYG environment. What you see is what you get. So all the math, all the calculations you are doing, you type it exactly in this document, and this document then becomes the report. So you don't need to do any extra work when going from your calculations to the final product. Here are some. Okay, so I'm not going to cover this slide. It's just more details of what's in Mathcad 1.0. Again, some other capabilities. We can obviously handle nice, pretty plots. We can do programming, and we can also integrate to other products, as I already mentioned, such as Creo and also Windchill. So now let's talk about Prime 2.0. I don't want to spend too much time here because I actually want to show you what these look like within the actual product. But here are some of the new features that you can look forward to. I'm going to be covering symbolic calculation and 3D plots, and also Excel and collapsible areas. The installation of Mathcad I'll be using right now is actually going to be a 64-bit installation. And what that means is that as all these computers go towards 64-bit, we can now address more memory. And as we can address more memory, that means that we can actually start tackling larger problems. So I think one of the first things that comes to mind is people who are dealing with very large data sets, whether it be with GPS imagery or just lots of data that they collected from test equipment. We can now actually handle them in Mathcad. There's also a thing here on performance. This is not something I will have time to show, but I will show you how you can access them from the ribbon UI. So with that, I'm going to jump into the live demo. What I wanted to do first is, for those of you, and I'm sure most of you have seen Prime 1.0, I want to show you some of the things that you can currently do in Prime 1.0. And then from there, I want to show you some of these new capabilities, and then I want to show you then how you can roll all those new capabilities up so you can actually enhance on what you could do before. So I know that's a lot of words, so let me actually just show you what I plan on doing. So I have this document here, and I don't want to go through the details here. Some of you might have already seen this demo. It's just a worksheet that computes the deflection in a beam, right? So if you're building a bridge, or if you're building a building, you have all these beams, and you want to make sure that they're strong enough to support a certain load. So this is a title page, and as you can see, you can embed header and also footer files right into this document. Now, if we go into the body of this document, this is what you've already seen before, right? We can put images side by side with calculations, and if we were to go ahead and change any of these calculations, then all the changes would actually propagate through the document, right? So these are all updating live. And as I scroll through here, more or less of the same thing. I do want to point out that whenever I define variables, I can either define them as just a number, or I can actually attach a unit there as well. So in this case, what I'm saying is I have a certain beam, 15 meters long, and applying a load of 500 newtons, and that load is going to be applied 15 meters from the left-hand side. Okay? So again, without going through all the details, there are a bunch of different equations that goes into calculating the deflection, and here it is. So these are actually equations that pulled out of a book, and now what I can do is actually calculate all these various these equations. So now once I have the equation, I can say, Well, then tell me how much the beam is going to deflect at the midway point, right? So L over 2. And I can calculate that's going to be about 13 millimeters. As I scroll down here, what I can also do is calculate the maximum deflection, because usually the deflection at the middle is not going to be quite the maximum deflection, so we can actually calculate a bunch of different numbers here. And now once I have all these numbers and equations, what I can do is plot them. So nothing fancy here. So I can plot both the shear, which is V, and also the moment. And then finally, I can tabulate all my data and put it into a nice table. This is my results. And then this is really my final table here, right? So this is the deflection in the beam. And as you can see, there are two vertical lines. The green vertical line is telling me where the maximum deflection is. You can see that it's pretty close to the middle, but not quite. And then the black line is showing where the load is being applied. If you remember, it was 11 meters. And then finally, if we wanted to get more advanced, what we can do is, you know that there are two different things that we can change. We can change both how much the load is and also where we apply the load, so A and W. And so if we want to visualize these two things being changed at the same time, obviously we can't do that with a line. We have to do that with a with more dimensions. So what we can do in Prime 1.0 is add a contour plot. So as you can see here, what you have here is you have, as you apply a bigger load, and as you apply it closer to the center, then what we're going to see is more and more of a deflection, right? And that's what this plot is showing. And then furthermore, one last slide here is that we also have a lot of optimization engines built into Mathcad, so we can actually have solve blocks. Now what this means is previously I have an equation. So given a load, I can find out how much it deflects. Now what happens if I want to work backwards? I can say, well, maybe this building, there's a requirement in there that says I can only have a deflection of 3 millimeters. Well, given that, then how stiff of a material do I need to pick it? And so now I'm using a solver to actually work backwards, and it's telling me, well, if you want to actually meet those requirements, then you must have an I value of a specific number. And then finally, given a specific I value, we can actually pick the the exact dimensions, because obviously we want to make sure that we don't waste material. So we want to we want to pick as little material as possible. So we can say, well, given those constraints, then what is the minimum base and height value that we can actually use to construct this particular beam? So this is all Prime 1.0 today. What I'm going to do is I'm going to jump right into my first piece, which is XL component. Now I do want to point out that, as you can see from the top here, this is Mathcad Prime 2.0. So Prime 2.0 is not officially out yet. In fact, it's still going through some testing. And that is why, if you watch really carefully, you might even see some bugs within some of the demos that I'm giving you today. But the whole point is here, I'm using a build that was basically just built last night. And so this is hot off the press, if you will. And so this is what we have right now. But all these bugs will be fixed. All these little bugs that you might see today will be fixed by the time it gets released in December. XL components. Now, you guys already know from before that if you want to read or write Excel files, we have a lot of different functions. For example, read Excel file. So what that does is it allows me to read in a file. In fact, let me just go ahead and show you what it looks like. So as you can see, it's reading this file, right? This battery watch. So if I go ahead and open up this folder and just open that battery watch, as you can see, I have a bunch of different columns. And so essentially what I want to look at is I want to look at these three columns. So I have a bunch of different points in time. I think each point is about, I think, 1 minute apart. And then round 1 and round 2 is measuring something from this battery. I don't know if it's voltage or if it's something else. But imagine that's some data that I've collected and I want to be able to visualize it. Let me actually put my windows side by side here so you can actually see a little bit better what I'm trying to do. Before I go on, I actually want to point out that there's already something that you might be able to tell right away, and that's different, and that's actually this nice header, right? So this header file is actually written in Excel. So if I go ahead and actually just double click on this, notice how it actually loads it up in Excel. And all these different fields that you see, whether it be the logo or the job number and so forth, these are all done in Excel. Now you can actually do this within Mathcad Prime, but if you try to line up boxes and text fields within Mathcad, sometimes it gets a little bit difficult. And given the fact that Excel is a spreadsheet, it's very easy to do things like this. So I can see that a lot of customers might actually want to do things, at least the formatting of headers and footers in Excel. So that's already the first sign of using Excel in this document. Now let me go back to what I was showing earlier. So I have this Excel document that I want to essentially plot, right? So let me open up this document again. Now what's happening here is this worksheet is being executed from top to bottom, right? So Mathcad opens up these files and it calculates this first row, and then it goes through. Now what happens is if I go ahead and go into Excel and change some of these values, let's say I change it to 100, right? These values will not get updated until I save this file and I re-execute my Mathcad worksheet. Because this line here in Mathcad is already executed. So if I want to update this, then I kind of have to run it again. All right. I mean, it's not a big deal. In fact, I mean, I think a lot of customers, they save their data to an Excel file, and then they just want to read it in at the beginning, right? So it might not even affect them. But what I'm doing here is once I actually have the raw data, I can go ahead and extract the various columns here. So as you might remember, I have a column for point and also run 1 and run 2. So what I'm saying here is extract the 4th, 5th, and 6th column, and then throw that out, and I can now plot them. So whatever these values are, right? As you can see, there's 2 runs, and they're both kind of decreasing with time. All right. So this is just taking data from Excel, and then parsing it out and then plotting them. So nothing fancy here. This you can currently do in Prem 1.0. Now let's take a look at what happens when we have Excel components. So as you can see here, what we have is the same table as before, but now it's embedded into the Mathcad worksheet. If I were to double click on this Excel component here, you will see that it brings up the same worksheet as before. Now this worksheet is actually not identical to the, this worksheet is not the actual worksheet that's saved in the XLS file. This worksheet that it brings up is actually, all this data is stored inside the Mathcad worksheet itself. And so what that means is, as I'm making these changes, all these changes will get updated within the Mathcad worksheet, and I do not need to save it as a separate Excel spreadsheet. So the first thing you'll notice that I do want you to take a look at this run 2 column. As I'm making these changes inside Excel, you notice that the changes will update in Mathcad. So if I go ahead and make it to 105, you notice that the first 2 values actually jump to 105. That's very useful. And so, I mean, again, there's different cases where you might want to use the read Excel, and there might be cases where you want to use the Excel component. Now, in this case, what I have is I already have the run 1 and run 2 data stored off as various parts of this Excel spreadsheet, right? So what it's saying is it's going. I'm not sure if you guys can read the text here, but what it's doing is it's going to sheet 1 and it's pulling out all the data from D2 through D148, and it's doing that for both run 1 and run 2. Now you could be asking yourself, well, that's great, but I mean, how do I get that syntax? Or if there's a specific set of data that I want to collect, how do I really need to go into Excel and actually pick the various buttons manually to get what the C2 or the D2 or the C148 are? So I want to show you a really quick way of doing that. So if I were to go ahead and select the data within Excel, right? So I can just select it, and so let's say this is all the data that I want to collect, that I want to be able to visualize within Mathcad. What I'm doing now is I'm actually selecting the data. I can come back right into Mathcad. I can right-click and then just say Insert Output Expression. So again, to recap, I want to select the data first within Excel. After I double-clicked on it, I want to keep it open, and then when I click on this, you will notice that now it gets populated with sheet 1, C2 through C148. And now what I can do is go ahead and save that off as a variable called point. So that's how I can very easily create these files from these variables from Mathcad using an Excel component. So now what I can do is go ahead and close my spreadsheet, my Excel spreadsheet. And if I now were to scroll down, I can now say, well, I want to plot run 1, and I want to plot run 2, and I want to plot that versus point, right? And you will see the exact same plot that we saw early on, but this time using Excel components, right? And you might also notice that, yeah, these 2 points are a little bit higher because you remember how I made them 85? I changed them from 85 to 105, right? However, that's actually completely independent of this file right here, because this file, remember, the worksheet is actually completely independent, right? So this is still reading it from that Excel spreadsheet, which is a physical file, whereas the Excel component that we're using here, all that data is actually stored right within this Mathcad worksheet. So what I want to do now is actually go into 3D plots. I want to kind of start off with a really simple example, right? So in this example, what I have is I have two matrices A and B, and I want to be able to visualize them. Given that these are 2D matrices, if I were to plot each A and B separately, so let's say I plot A and B, I can look at individual rows. So in this case, what I'm doing is plotting the first row, the fifth row, and the 10th row, right? So as you can see, they're all a little bit different. They kind of look like sine and cosine waves, but it's hard for me to see exactly what they look like. It's hard for me to actually understand what the whole matrix looks like. Now, previously in Mathcad Prime 1.0, what I could have done is, like earlier I showed you, I can add a contour plot. And this will give me a little more data, right? So it's showing me, okay, there's some sort of a trend here. It kind of looks diagonal in nature, but still it's kind of hard for me to understand what's going on. So if I go ahead and delete that, what I can now do is insert a 3D plot. So in a 3D plot, I can go ahead and say A and B. And as you can see, now I actually get these surfaces, right? Now you might actually argue that's still a little bit hard to see, so let's go ahead and actually fill these in so it's easier to see. So let's go ahead and pick A, and let's go ahead and make A blue, right? And we'll do the same thing with B. And maybe you make B red. So now you can actually see the two different plots, right? The two different surfaces. A, as you can see from before, kind of has that diagonal pattern, right? So if I looked at it straight down, obviously there's a diagonal pattern in two directions. There's one going this way. Oops. There's one going kind of this way, and there's also one going this way as well, right? So you can exactly see the different trends in these two different surfaces, right? So I think, I mean, obviously, 3D plots isn't meant for all data, but I think for certain types of data, it makes a lot more sense to visualize in 3D. Okay, and just like you would imagine, we allow you to rotate, we allow you to kind of pan around, and also if you want to zoom in and zoom out, we can do that as well. And in case you kind of get to a kind of really weird spot, we also have a button here that allows you to reset the view. So we click on it, and it goes back to the default view. Now this is one way of plotting 3D. I also want to point out that, for example, I might actually have data in an XLS file. So, using the same trick as before, I can go ahead and call the read Excel file, and all my data that's being stored in Excel will now be basically visualized here in Mathcad, right? So again, many different ways to pull in data. All right. Now here's another one. In this one, what I'm doing is I'm actually I have three different columns, right? So each column for X, Y, and Z. And what I'm going to do is put them all side by side. So if I were to actually take a look at this right now, if I were to say equals, you can see that it's just three columns. So if I were to pass three columns to Mathcad, what it's going to do is it's going to imagine that each row is a point, right? So X, Y, and Z. And that's why you get all these various dots. Now these dots might not be very meaningful. So what I might want to do is I might want to connect them with a line. And as soon as I connect them with a line, you notice that it now shows you a nice little spiral, as you would imagine with sines and cosines, right? So we can plot surfaces, and we can also plot curves. Now let's show you yet another way. Right now, all of these plots have, require that you insert some sort of an equation before you plot it, right? So I needed to first either pull in some points, or I needed to use sines and cosines to generate some equations. But now what I can do is I can actually insert my equation right into the plot. So in this case, V1 stands for X, V2 stands for Y. So what that means is this function now is going to, this plot is actually going to change based on this function. So as I change these values, I'm not sure if you were able to see any changes here, but actually let me make a more drastic change. So as opposed to X squared, I'm now going to cube it, so X to the third power. As you can see, now I get a drastically different plot. And I also want to point out here that by default, we pick 11 points per dimension. Right, so that's why you see these little squares here, and there should be 10 of them, right? Now what I can do is I can actually increase them. So let's say I wanted 41 squares or 40 squares. per side. So as you can see now, this grid now becomes a lot finer. All right, so we can actually, if you were to generate plots this way, we allow you to actually adjust the resolution of your plot. And finally, one last way is oftentimes if you hear customers say they want to create a parameterized plot, so basically what we have here is we have X, Y, and Z as before, but now what we're going to do is parameterize them with U and V. So in order to do so, what we need to do is first create a mesh of U and V. So I'm going to create a mesh of U and V, 60 points in each, both U and V. And now we can actually create what this plot looks like. So I believe in the US this is what we call a donut, right? Kind of looks like a toroid. What I also want to do is just point out that just like as you would imagine, all these things update live. So if I were to change any equation, the plot actually gets updated automatically. So now I want to briefly cover symbolics. I want to take an example that I showed you earlier on from my bean loading example. So in that particular example, what I have is I copied a bunch of equations from my textbook. Now, what I might want to do is copy the main equations from my textbook and then derive the others. Now, that might be useful because you might actually have, as you're copying equations from a textbook, you might make some mistakes. But if you copy the fundamentals and then you derive the rest, then you can be sure that all your calculations are going to be consistent. So in this particular example, what I've done is I've copied my equation for a deflection. All right, so that's this equation right here. Now what I'm going to do is actually calculate the maximum deflection. And I can do so by using a bunch of different calculus. So for example, I need to first take the derivative of that equation. And I can just say dy dx is equal to, and notice how when you're dealing with symbolics here, right, as opposed to using the equal sign, you see an arrow. So whenever you see an arrow, what that means is now we're going to ask for the answer in terms of variables, right? So as you can see, the answer comes back in terms of W, L's, and A's, and also E's and I's and L's, as opposed to the actual numbers. And same thing over here. What I'm now going to say is, when the slope is 0, what is the value of x? Well, the value of x is going to be a times a minus 2l and so forth. Now, the interesting thing is, if I now compare this equation to the equation I had in my worksheet, it's going to be identical, right? So that's a good thing. That means that I didn't make a mistake when I copied the equation. Or what that means is I could have actually just derived those equations directly from Mathcad without actually having to copy the equations. Now the whole point with symbolic is that you can calculate them all symbolically, but at the end of the day we still want to plug in real numbers. So in this case, what I'm going to do is take in this expression, right, and then substitute, put in 11 meters for A and 15 meters for L, and then want to calculate where the maximum deflection takes. And that's why you get the two different values, right? So 8.3 meters and also negative 8.3 meters. Now at this point, I'd like to tell people, hey, listen, Mathcad will give you all the solutions that are out there. Now this is where engineers still kind of need to think about it for a little bit. So you have two different answers, but which one are you going to pick? I have a length from 0 to 15 meters. So it really doesn't make sense for me to have a negative length. So really, the only solution here that makes sense is the 8.3. And I can take that and plug that into my original equation, and that's how I get the 13.3 millimeters. All right, so you might actually recall that from my original document. So in fact, you know what? Let's go ahead and show you my original document, but with some of these new features. All right. So this is the exact same document from before, but now as I scroll through, I want to point out what I've added in here. The first thing I want to point out is that you notice that this nice little thin red line here. So this is collapsible regions. This is something that I mentioned earlier on, but I haven't shown you yet. So if I go ahead and click on this plus sign, right, notice how it expands. And notice how all the different calculations that I showed you earlier are now posted right in here. The reason for this is, this derivation might be very useful, but for an end user, or for my boss who wants to read this document, he doesn't need to go through all the calculus, right? He just wants to see the final answer. So it makes a lot of sense for me to actually keep all these calculations within my worksheet, but put it into a region or a collapsible area that allows me to very easily, hide it as well. So that's one of the things I've already added. The second is that, as you can see here, I have another collapsible region here. Now this is another perfect example, right? So right here, all I'm doing is I have some setup variables. And so I don't really care about whether they're seen or not, because they don't really add any value to the overall worksheet. So what I can also do is put that into a collapsible area. Another use of a collapsible area is, let's say you have some intellectual property, some IP that you want to protect. and you don't want to share with share with other people what they are. So what you might want to do is put those sensitive information into the collapsible area, collapse it, and then when you print to a PDF, you can now share with anyone that you want, and you will only see the portions that you want the customers to see. So now all these calculations are still the same, but what I want to finally show you is finally this contour plot. Right. So early on I showed you this contour plot that varies as both load and also the distance from the side. Now this might actually make some sense to you guys, but I actually think it makes a lot more sense to visualize this in 3D. A lot of people will call a contour plot a poor man's 3D plot, and as you can see from this example, that's exactly what it is, right? So what we were seeing before was basically if we were to look at this plot exactly square down, like from a bird's eye view, as I increase x, or actually as I increase y, which is my load, and if you're confused as to which one y is, right, I can select. I'm not sure if you can tell here. I can select on the y-axis, and it will highlight the axis for me, right? So that's I know it might be kind of difficult to see in the room, but when I select Y, this axis now actually becomes blue. So as I increase the load, as you can see, the maximum deflection increases. And as I were to actually apply the load more closer to the middle of the beam, again, so that'll be right here. The middle of the beam is right here, right? Then the load also increases. So I think adding 3D visualization to this particular plot makes a lot of sense. Yeah, I can take something that's something that already works, the document that I showed you in the beginning, but by putting in collapsible areas, by adding in symbolics and also 3D plots, I can now greatly enhance what I can add to my final document. So there's one last thing I want to show you guys. I guess really point out, and that's actually calculations. So earlier on, I told you that Mathcad Prime 2.0 has implemented a bunch of performance improvements. So one of the things I want to point out is multi-threading. Now, most of the machines these days have actually multiple cores on their machines, and so what we can now do is spread out some of the processes within your Mathcad worksheet, so it takes on multiple cores or multiple threads and multiple processes. I do want to point out that even though I can't show you, the effects of using multi-threading, that it's not always a great idea. I mean, for the most part, it's a good idea to use, but there are certain problems that actually multi-threading might hurt you. And we can talk about the details later, but effectively what it is that if you think about it, when you want to split your work up across different processors, there's an overhead involved. So for certain types of problems, that overhead actually might cost you more time than the time it's going to save you. So I just want to put that out there. Multi-threading for the most part will help you, but there might be instances where it might actually slow down your computations a little bit. So with that, I just want to jump back into a couple slides here. Prime 2.0, obviously, we've added a lot more features in here, but there's still quite a few things that customers are going to be asking for, right? So I think the first two things is templates and controls. Now, templates means a couple different things to different people. So what we mean is, if you want to go ahead and specify a template that determines your header and footer, right now what we do is we put them in manually. But you can actually have essentially a template file that will dictate how your all your files look. So that's something we can't do quite yet. And also controls. You might want to have buttons or sliders or drop-down menus. That was available in 15, but we don't have that yet. So that will be coming out in 3.0. And I'm sure you guys hear this all the time. People asking for a sketcher, or people asking to integrate Mathcad Prime to some other software tools that aren't currently supported. So what they need is our published APIs. So that will be coming out soon. And also just more integration with some of the existing tools that we already integrate to. This is just to kind of remind you again that Mathcad Prime is going to be developed. Obviously, moving forward, it's going to be the only one that's going to be being developed. Whereas 15 is still going to be maintained until we catch up. So here's kind of a schedule for a timeline, if you will, of how we plan on scheduling those things. And also, if you want to break it down into some of the various strategies that Brent already mentioned, so the personal, the collaboration, and the process. Moving forward, we definitely have a lot of things that we plan on implementing into Prime. So, and I do want to point out that as you guys go out and as you guys talk to customers, if there are certain trends or there are certain things that you are seeing or that you're getting asked a lot from your customers, definitely feel free to let us know. I mean, we're always trying to figure out what's the next thing that we want to put in that will make our tools more widely used.
Roger, thank you very much. Greatly appreciate you doing this remotely so early in the morning.
All right, best of luck to everyone.
Thank you.